Alright, this is going to be a video on single displacement reactions. A single displacement reaction is when one atom takes the place of another atom in a compound. So, for example, A plus BC goes to AC plus B. A is an element that can take the place of B in that compound. So A displaces B and it becomes AC. The way this is written, we would assume that A and B were both cations or metals. Alternatively, A plus BC can go to BA plus C, and the way that is written, we would assume that A was an anion, and as a result, it's displacing the anion C in that compound. The point here is that the atom that gets displaced in the compound could be either the metal or the non-metal. It doesn't make any difference. Either way, we still consider it a single displacement reaction. One atom displacing another. Some atoms like to be ions and in compounds more than other atoms, so this occurs if that is the case. And we'll, in a follow-up video, discuss how we can tell if this reaction will actually happen or if it won't happen. So just as an example, lithium would displace the copper in copper 2 chloride. Like I said, some metals like to be in compounds more than other metals. Lithium, it turns out, really likes to be in compounds. So lithium would displace the copper in copper chloride. This reaction would typically occur in a solution. So lithium would be a solid, and it'd be added to a solution of copper chloride. It says copper 2 here, so if we imagine our crossover, plus 2 and minus 1, we get 1 and 2. That's how I came up with that. Would become lithium chloride. See, lithium took the spot of the copper. Here we'd have plus 1 and minus 1, so when you cross them over, it'd be a 1 to 1 ratio. Plus, copper metal would come off as a solid. This reaction would actually happen, and it wouldn't happen the other way around, and that's an important aspect of copper. Copper makes a good element for stuff that you want to last a long time, jewelry, money, stuff like that, because he really doesn't like to be part of a compound. He really just wants to hang out as a solid. And so the fact that it wants to stay as a solid means that it is good for something like money, because of course we don't want our money to dissolve away. It also happens to be rare enough that it works for that purpose too. Balancing this, we can see we have 2 chlorines here, so I have to add 2 to the chlorines here. And then that means I have 2 lithiums. Typically, to make this reaction work, we would have these compounds, copper chloride or lithium chloride, dissolved in water or aqueous. Aqueous, is the symbol we use to say dissolved in water. So if we're really thinking about this reaction, what we would have is a solution that contains copper chloride. Copper chloride is blue, so this would be like a blue solution like this. And we'd put in a chunk of lithium, so we'd throw in this chunk of lithium. And what we'd see is that the lithium would go in a solution, and so at best what we would see is this hunk of something dissolving into the solution. But then what we would also see is a reddish cube forming. It might form on the surface of the old lithium, or it might form somewhere else, and that would represent the copper coming out of solution. So lithium goes into a solution of copper chloride. The chloride just stays in solution the whole time, but the lithium takes the place of the copper in the solution, and as a result the copper can come out as a metal. That's how this reaction would happen in real life. Well, except that the lithium would react with water and it'd do this whole other thing, but practically that's how double displacement reactions happen. Similarly, chlorine would like to take the place of bromine in solution. So if we had some chlorine gas, oops, that should be in the bottom. Let me try that again. Cl2 bubbled into some lithium bromide. And here we'd probably have this as aqueous again. And this would be a gas, but that gas might be bubbled into the liquid. And this, when I do the crossover here, +1 and -1, so when they cross over you get your 1-to-1, would form lithium chloride, and then the bromine gas would come out. Not great, since bromine gas is pretty poisonous, but chlorine gas was too, so you know, one for the other. Anyway, so the chlorine would take the place of the anion in this situation. So chlorine would take the place of bromine, and then the bromine would be free to be a gas. Balancing this, I have 2 chlorines, so I'd need 2 chlorines, and I have 2 bromines, so I'd need 2 bromines. And then if I look at my metals, 2 lithiums go to 2 lithiums, and I'm balanced. Practically what really happens here is the lithium would just hang out in solution the whole time and wouldn't even really be aware of this reaction. It's really just the chlorine going into the solution and the bromine coming out to replace it. So the chlorine displaces the bromine. One more quick single displacement reaction I want to make sure I show you is the idea of sodium reacting with water. The trick with water, when thinking of it in single displacement reactions, is not to think of it as H2O. Instead, you should think of it as a cation, hydrogen, bonded with an anion, OH-. So H plus can act as a cation, and the polyatomic hydroxide can act as an anion. And this is really what water is doing when it's acting in reactions. And it's important to recognize that if we're doing something like reacting it with sodium. Because what's going to happen here is that sodium is going to take the place of the cation, or the positive hydrogen, and that will displace that hydrogen to form hydrogen gas. And so the sodium would take the place of the hydrogen, and then that's that. If I put states on all this, this would be a liquid, this would be a solid, and this would be aqueous, or dissolved in the liquid. So that sodium would take the place of the positive, so it would be sodium hydroxide. Then the hydrogen would come out and become hydrogen gas. If I want to balance this, see my hydroxides stay together, so I'm going to think of them like one thing. So I'm going to put 2 on this to balance my hydrogens. And then my hydroxides are unbalanced, so I'll put 2 on this. And now my sodiums are unbalanced, so I'll put 2 on this. And I have 2, 2, 2, 2 sodiums to 2 sodiums, 2 4 hydrogens to 2 4 hydrogens, 2 oxygens to 2 oxygens. Or probably the better way to think about it is 2 hydrogens to 2 hydrogens, and 2 hydroxides going to 2 hydroxides. So those are single displacement reactions. If they'll occur or not, we're going to need to learn about the activity series, and I'm going to do that in the video that follows this video.